Welcome everyone. Welcome to the center session of the Future Scientist. I'm James B. Barbieri. I'm the Associate Program Director here at the Participatory Center, and I will be your host for today. So any problem, technical or not, feel free to just message me in the chat. Today, we have the honor to be joined by Rupert Sheldrake and Alex Gomez-Marin. Rupert is a biologist and author of more than 90 technical papers and 9 books, including The Science Illusion. He was Fellow of Clare College in Cambridge University and Research Fellow at the Royal Society. He also was the director of the Perils project for the study of unexplained human and animal abilities, founded by Trinity College, Cambridge. Rupert is also currently a Fellow of the Institute of Noetic Science in Petaluma, California, and of the Schumacher College in Darlington, Devon. Alex is a theoretical physicist turned cognitive neuroscientist and chair of this series. He has a PhD in physics at the University of Barcelona and is the Juan de la Sierra Fellow at the EMBL CRG Center for Genomic Regulation and current head of the Behavior of Organisms Laboratory at the Instituto de Neurociencia in Alicante. His current research concentrates on consciousness and cognition in humans in real-life situations, combining theoretical biology and continental philosophy. So a very warm welcome to both of you. Today, Rupert and Alex will be in conversation where they will address the weak points in contemporary science in areas that might be promising for breakthroughs, accelerating a change of paradigm already underway. Before we begin, I'd just like to very briefly go through a couple of guidelines for this call. First of all, if you could please mute your microphone to avoid any background noise, but at the same time, we do encourage you all to turn your cameras on. Throughout the call, please do use the chat. It's a great way to share your ideas or any thoughts that you have of the topics that arise during this call. We do, however, ask you to have an open dialogue in the chat and respect each other's ideas and opinions. And finally, this session is recorded for archival purposes and for you all. The recording should be available on Vimeo in about 3 days' time, and you should all receive the link when that is ready. And with that, I'll pass it straight over to you, Alex. Welcome.
Okay, thank you, James. Thank you, Eleanor, and the whole Paris staff for supporting this initiative and many of the other initiatives that you have virtually and also in person. And I'm really, really honored to have Rupert with us today. Rupert is a great scientist, a very unique one. He's a wonderful person, and I'm blessed to say that he's my friend as well. So that conversation is very emotional to me at the same time. Now, Rupert and I have been talking, thanks to Zoom, for many, many hours, but this is the first time we do it publicly. And I know we can talk about many things for a long time. And we'll try to compress it, but at the same time not rush, and touch on some very interesting topics, I think, about the recent past of science and also the likely or hopeful future. Let me just say 3 things within the Future Scientist series before we begin. One is for those of you for which this is the first time, because we had this other conversation a month ago with Ian McGilchrist. So we're looking back at science, where we are now, where we're coming from, rather critically, but also hopefully imagining where it could go and where we want it to go. So these things don't need to go together. But it's a very kind of ambitious exercise we're doing it. And we're doing it also by bringing different people so that we can have different perspectives, different expertises, but also different temperaments. So if you continue attending to this series we do once a month, you'll see I think you'll be able to have in your mind this kind of collage of different viewpoints as to how the future scientist may look like. Well, that's the hope. And finally, let me say one more thing. So, because I'm learning from this, and there was interesting feedback from the previous session that, of course, many of you, probably most of you, are coming here to listen to the invited speaker, right? Because I have the honor to host Ian McGilchrist, Rupert Sheldrake, and others. And of course, you may think that, to put it nicely, that I'm talking too much. And so I'll try to not talk too much, but at the same time, let me remind you that the format of this is a conversation. So it's not a format where I'm interviewing or where we hear a lecture. And it could be that sometimes I extend myself, but I'll try to do better. But it's very important that we explore this conversation medium where Rupert and I, in this case, will pretend we're talking as we do in private, but also having you listen, and then of course, be very happy to have questions. Okay, let's start. So this book was published 40 years ago, 1 month after I was born. Rupert published A New Science of Life. And what happened is that a few months later, there was this article where it was called A Book for Burning, ? Basically, Rupert's ideas here, which are really wonderful and are still valid today, I think. It was called a scientific heresy. So I wanted to start, Rupert, by asking you, how come, so what happened and how come during these 40 years, because I know you, I've seen you're not bitter or angry, you're actually joyful and creative. So despite this harsh, in a way, attack on your own scientific proposals, you've been thriving in a way. So it would be great to hear about that.
Well, when I put forward the idea of morphic resonance in that book, A New Science of Life, first in 1981, I was well aware that this was a heretical idea. I first thought of it in 1973 when I was a fellow of Clare College, Cambridge. And I discussed it with my colleagues in the biochemistry department, among the fellows of Clare College, and within the scientific community. I knew a lot of scientists, of course. And I realized that for most scientists, this was just something completely off the charts of anything that they would want to think about. Most of them thought science was doing perfectly well as it was. There was no need to come up with new ideas, especially not very radical ones about a memory in nature. And some actually got angry at the idea of challenging established science. So I knew perfectly well that this was a step that I needed to consider carefully. And I thought about it and did further research and thought the ideas through for 8 more years after thinking about it before I published the book, because I wanted to be sure that I could defend this point of view, and also that it was reasonable and that it wasn't just a crazy idea. So when the book was published, I wasn't surprised that there was an adverse reaction. I was surprised at how strong it was and how prominent it was. But I'd read History of Science, I studied Thomas Kuhn, I knew that paradigm changes were controversial, that people got upset because they're attached to old paradigms. This happens whenever there's a radically new idea comes along. It's inevitable. So I didn't take it too personally. Of course, I was subjected to a lot of unjustified attacks, a lot of very unfair personal attacks, which were upsetting. There's no doubt about it. But in a way, I was prepared for that to happen, and I was ready for it to happen. And so when it did happen, it wasn't totally a surprise. And I sort of realized if I was going to do this, I had to be prepared for that. One of my colleagues at Cambridge warned me that this would happen. And he said, why don't you just keep quiet about these books, these ideas? He said, you can get a professorship, you can rise to a high level in science. And then when you retire, you can take up these ideas. I thought, really, I didn't really want to wait 40 years before I do what most interests me. And so I did it anyway, but I wasn't totally surprised.
And it doesn't actually happen. I mean, every case is a particular case, but in my experience, even when you get tenure or people say, okay, I'll get tenure, so in a way, now I can do whatever I want, but one is not, I mean, we're never completely free, right? I mean, and constraints are good actually, but even when people get tenure, they still need to feed all the students of the lab and get more grants. So in a way, that's never like the moment to just do it, or postponing it could be just an excuse not to do it. At the same time, doing it too early, and maybe that's something we can talk about right now, which is that there are many students who would probably like to investigate all these ideas and experiments that you've proposed, but that's perhaps not really good for them, because first, sometimes there's not even a PhD program to do so. And second, if they did, they would not continue their careers, right? So already there's a huge selection, a huge bottleneck that somehow you've managed to bypass, and as I was saying, thrive on it. So you're an example that this is possible, but it will be misleading, I guess, to paint the picture that in any case you can get on with it, because there's a huge bottleneck, I think.
Yes. Well, I think right now it would be hard to advise anyone to pursue controversial science if they've got a mortgage to pay and a family to support. When I published this book, I was unmarried and I didn't have a family to support. And so that wasn't so much of a problem for me. But I think one of the things we might discuss is that the situation may change. Until recently, science funding has depended on grants through large national or international organizations, and they depend on conservative committees, peer review, anonymous peer review. They're highly competitive. People don't want to do anything too daring because they're afraid they won't get the grant. However, there's now other sources of funding, thanks to the fact that the world has never had so many billionaires. And some of them have become billionaires because they're into tech industries. And some of them are genuinely curious about science, and because they're very, very rich and they've got nothing to lose, or very little to lose, except their fortunes, some of them are now prepared to fund unconventional science. I myself have been funded by wealthy individuals, and on a very modest scale, but I mean, I have them to thank for this, because I couldn't have done all this without some funding. But I think that the possibility of sources of funding from non-conventional sources and from new foundations, or from existing foundations becoming more adventurous, could give us a plurality of sources of funding, which might open things up.
Yes. Funding is one aspect, of course, a very important one, because you need to pay, as you're saying, the rent and so on. But then there's another force that's more sociological, I guess, that even if you have the funding, at least I speak from my own experience, right? I mean, I've been switching across fields. So in a way, I don't care getting somewhere new and doing things my own way. But when I talk to you and we're exploring together certain themes, I feel a slightly different barrier, because one thing is to give a talk that's interdisciplinary, where you're like, as a physicist talking to biologists or psychologists, listening to evolutionary biologists, for instance. Well, yes, we know we come from different tribes, but I mean, without emphasizing it too much, but this distinction between orthodoxy, heterodoxy, and then heresy, like the moment you're in the heresy camp, even if you have funding, it's, I would say, difficult to get your ideas across, to get them published. And also your peers, even though in public or in private, they will be familiar or even friendly with them, in public, they're still in the closet, right? And I think you've been doing great work in showing that it's possible to be out of the closet. But when we talk, you often tell me these experiences where you give a lecture and talk about a topic, you could say telepathy, for instance, which would freak out many of my neuroscience colleagues. But then in the questions or in the coffee break, some people may actually tell you that, well, they've had similar experiences. Of course, that doesn't prove it scientifically, but you see a huge divide within the lives of people.
Absolutely. I mean, there's much more open-mindedness within the scientific world when you talk to people in private than in public. And I think it's the public culture of science is extremely intolerant and dogmatic, unfortunately. It's, you know, I think it's worse than almost any other branch of human endeavor. In politics, we're used to there being different political parties. You know, in Britain, we have sort of Conservatives, Labour, Liberal Democrats, Greens, nationalist parties, and so on. And there's a debate between these different points of view. And there isn't the idea that one of them and one alone is correct. That's the attitude you get in totalitarian states and dictatorships. And unfortunately, the culture of science is much more like a totalitarian state than like a democracy. And I think this has been built in from the beginning, because the foundation story of science, its myth, as it were, is the struggle of Galileo and his accusations by the Roman Inquisition of heresy. And so the idea is that science was a rebellion against this dogmatic structure of the Roman Church. And so scientists like to think of themselves as free thinkers, rebels, going against dogmatic orthodoxy. But the trouble is they've internalized exactly that thing themselves, and it's become a dogmatic orthodoxy, which is a great shame. It could have been otherwise. Even in the realm of religion, you see, we have, if you don't like the Roman Catholics, you can be a Protestant. And if you're a Protestant, you can be a Protestant of many different kinds. And if you don't like any of them, you can be an atheist, or you can be a Buddhist, or you can be a Muslim or a Sufi if you're a Muslim. Or there's a wide range in the realm of religion. But in the realm of science, there's the idea of a universal orthodoxy taught the same in schools in China, Russia, South America, Europe, North America, and so on.
Yes, and studying a bit of history of science, which is, it's a long corpus. And again, we don't have time often because we need to write grants or do our work. But you realize that most breakthroughs were done by people who, in a way, didn't care or were brave enough to just say, well, let's assume now that energy is not conserved, or let's postulate this virtual particle exists and it transforms into this other one. But I don't know if you see this as going worse or better, because sometimes you see optimism in the future, but also my feeling is that the last 100 years since the revolutions in quantum mechanics, and maybe it's because the world wars, I don't know, but there's been kind of a stagnation that it seems that it's getting back to full force in consciousness studies. We may talk about this later, but how do you see this trend of dogmatic skepticism, which, by the way, is I like these oxymorons, these words that seem to contradict each other, like scientific heresy and dogmatic skepticism. Mm-hmm. So how do you see the dogmatic skeptics and this trend going?
Well, I think that within physics, the quantum revolution opened things up, and cosmology, since the 1920s, physics has undergone several revolutions. One was the quantum revolution, the other was the cosmological revolution, the discovery of galaxies beyond our own, and the fact the universe is expanding. In 1966, when the Big Bang theory became orthodox, we had a radical shift in our cosmology. Before that, physicists thought the universe was eternal, slowly running out of steam, heading for a heat death, according to the second law of thermodynamics. And then this evolutionary cosmology made the whole of nature evolutionary, not just biology and human life. So physics has sort of opened up, and now within physics, it's possible to talk about multiple universes, radical interpretations of quantum theory, reverse particles moving backwards in time, and so on. On the other hand, over the same period, biology has closed down. It's become more and more dogmatic. There was a real debate at the beginning of the 20th century about the nature of life, with a wide range of views. There were vitalists like Bergson and Hans Driesch in Germany, who thought that life involved more than mere physico-chemical mechanisms. But the dogmatic mechanistic view came to triumph by the 1920s. And since then, anything else has been treated as heresy. Mm-hmm. And this led to a very narrow dogmatic reductionism within biology, which was accelerated by molecular biology. Mm-hmm. And in psychology in the 20th century, we had this arid school of behaviorism, which virtually denied consciousness. Now, things are changing through consciousness studies, which we can come back to. But in biology, that dogmatic molecular reductionist approach is still the predominant approach. It's loosening up a little bit, because of the discovery of epigenetics and because of the so-called missing heritability problem, the fact that things just aren't working out as predicted. But it's still locked into that dogmatic reductionist paradigm. And the fact that dogmatic mechanistic materialism has become closely allied to militant atheism means that people who are militant atheists, who are a minority within science and within society as a whole, but they make a lot of noise and they're very influential, people like Richard Dawkins, Daniel Dennett, Steven Pinker. Militant atheists have created a kind of religion out of atheism. They want to convert people to it. They're proselytizing atheists. And for them, mechanistic materialism is essential. It's an absolutely essential part of their worldview, which, and to challenge it challenges their most fundamental belief system. And they're not going to go away, and they're not going to stop being dogmatic because it's so important for their personal worldview.
Yes, and at the same time, it seems they, at least that's what happened in neuroscience, where I talk to my colleagues and I point, well, I don't point to their dogmatism or their religious beliefs, even if they're scientific in a way or scientistic, but I point them to their philosophies like mechanism, reductionism, materialism. I know it's many isms, but they are there. It's like, in a way, it's like the core values of a company that even if you don't know them explicitly, that's what you're working for. And what's frustrating to me, even sometimes it's entertaining, but it's ultimately frustrating, is that they say they don't have any. You know, it's very weird. It's like you're trying to make the distinction. Well, see, you're believing these things, but you could also believe in that. And then not even the solutions or the answers, like the problems would transform, just how you pose them, it would transform. It's like upside down, and then you would make other questions. And it's very strange that I feel sometimes they don't really acknowledge that that's going on in their mind. So it's these echo chambers, and I don't know to what extent it's worthwhile trying to engage across echo chambers, or just do your own thing and everybody to their best.
Well, I think that it's important to appeal to people's curiosity, and a lot of people went into science out of some kind of curiosity. And so I think it's important to appeal to that side of scientists. And I try and do it myself by partly through dealing with major unsolved problems within biology and consciousness. And I think it's possible to do that. The people who are most impervious are the militant atheists. And I think that they're the ones who live most intensively within an echo chamber. But they're a minority. And I've found that, in fact, surveys carried out through the Scientific and Medical Network in Britain, Germany, and France 3 or 4 years ago showed that about 45% of scientists, engineers, and medical professionals in those countries consider themselves non-religious. About 45% consider themselves spiritual and or religious. And that the number of committed atheists is about 25% in most countries, slightly higher in France than in Germany. England's in between. But it's not a majority. And a large number of scientists are actually open to spiritual, religious, and therefore wider views of consciousness. But they don't say so in public. So it's definitely not a uniform picture as soon as you look at people's private beliefs. And many of the people who don't believe in, who are not fully committed to mechanistic materialism, I think would gladly change if there was an alternative model in science and they could still go on doing science and getting jobs and grants.
Yes, alternative model and also findings, right? So maybe we can talk about contemporary science and what you call stress points or weak points that, but in a way, it's not just to break them, but it's places that you've identified over these years, as you say, for accelerating progress, like the sweetest points to pinch, as if you were doing acupuncture and trying to get out of that the most of it. And there are many that are you'll be surprised, or at least I'm surprised sometimes, that they are not too spiritual, if you want, or too spooky. These are like everyday phenomena. Also, in a way, you could consider them very classically within biology or psychology or neuroscience, but are totally fascinating. And you've been spelling out some of them. So let's talk about any of those you'd like to comment on.
Well, there are some very major problems within biology which are completely unsolved. And one of them that's fascinated me since I was a child is how pigeons find their home. And this is part of the larger problem of animal navigation. Migrating animals can find their way over hundreds or thousands of kilometers with quite great precision. For example, swallows migrate from Britain to Africa, to southern Africa, every autumn. They migrate back in the spring and they find the very same place where they nested the previous year. So it's pinpoint accuracy. It's not just a vague, head vaguely towards Britain. People have been trying to solve this problem for a very long time, and all the conventional things have explanations have been ruled out. What most people would say now, if you ask them, is that it's magnetic, that it's a magnetic sense. But when you think about it for a few moments, you realize that can't be the full picture, because even if birds and other animals have a very accurate magnetic sense, it would tell them where north is, but it wouldn't tell them where home is. And if you were parachuted to an unknown place with a very accurate compass, you wouldn't be able to find your home. However accurately you could measure the position of north, or even the dip of the compass, which would give you longitude. So there's a fundamental problem there, and I think it's because there's a new kind of connection in nature. I think in biology there are new kinds of fields that are not the known fields of physics, and that these explain a wide range of biological phenomena, and without taking them into account, the problems will never be solved. So that's one area, homing pigeons. Another area is the sense of being stared at, or scoposthesia. Many people have experienced being stared at, turning around, finding someone's looking at them, or looking at others and making them turn around. There's good evidence that this really happens from experiments. It happens with animals too, and it suggests that something's going on which just isn't explained by the current view that vision involves light coming into the eyes, changes, images on the retina, changes in the brain, and then everything you see is supposed to be inside your head. Again, this suggests there are extended fields, or some influence, let's put it in the most neutral way, that goes out when you look at things, as well as light coming in. And again, this is a phenomenon, if it exists, is probably of great evolutionary significance. If prey animals know when predators are looking at them, they'd escape better than animals that don't know or don't feel it. These are just two examples of some of the many unsolved problems within biology, which can't be solved with a dogmatic mechanistic materialism, which rules out the possibility of any kind of explanation that doesn't fit into an existing present-day physics textbook.
And they wouldn't be really so hard to test. That's one thing that I'm still surprised. I mean, careful science, and it needs to be repeated and repeatable, but we are not talking about a large hadron collider or like a telescope that costs billion necessarily. I mean, part of your strategy over the last years, and I don't know if this is going to change or it can flow in other directions, has been to do, in a way, to anticipate to many trends in science now, like not necessarily citizen science, but to do experiments outside laboratories without necessarily using very expensive technology and even expertise in running those. And also something that I find fascinating is that, look, like you've written about dogs and cats, and you were mentioning pigeons, right? But what we study in labs are rats and mice and fruit flies, which are fascinating. I mean, the research there is fascinating, but it's like we are alienated from those animals because we don't know them much. They are in cages, so they are also alienated from their own ecology, if you want. but you bring it back to real life, real people, real animals, and also common experiences. And that poses a very interesting, I would say even creative friction, clash between the common experiences of people and what the experts say. And then there's this strange loop where, and we're generalizing here, but the expert says, oh yes, whatever, people believe, but we know this can't happen. And why do we know? Well, because it can't happen. But why? Well, because the theory doesn't allow. And he said, well, but what is the theory based on what evidence? And then we go into this strange loop, right? Where you're fighting with evidence and prior expectations and beliefs. And then the theory says it cannot be done. And even if you did, it wouldn't work because the theory says it's not possible. So it's very strange, but at the same time, it would be theoretically easy to escape this loop because you go and test it and you do it again, and then you figure out. And let me just add, people would love it. People would love it. Like, of course, people are amazed, lay people, when we say whatever, like new gene discovered that could cure, it's always a potential future, right? Could cure this disease. But also if you found these effects that you're mentioning, that would not just validate the experiences of people, but they would be super engaged, like the general public would be super engaged with scientists. So it's again a way of reconnecting all these, like labs and real life, scientists and people and questions and so on.
Well, yes. I mean, when I did my research that I summarized in my book, Dogs That Know When Their Owners Are Coming Home, I worked with lots of pet owners and did experiments with them coming home at random times in unfamiliar vehicles. And many dogs anticipate the arrival of their owners 10 minutes, half an hour or more in advance sometimes, in a way that can't be explained by routine or familiar sounds. Now that work is about 50% of dogs and about 30% of cats do that. So there's millions of animals doing this all over Europe every day. So I found that this work really does engage people, and it does get people interested in science. Well, it gets normal people interested in science. It doesn't get some of the more dogmatic scientists interested in it. But there are some areas where these looking at things that are ignored or neglected could actually be useful. And another example is prediction of earthquakes. I've been interested in this for a long time. Before all the major earthquakes and tsunamis in recent years, animals have been observed to behave strangely, both domestic and wild animals, in the hours or days before the catastrophe. Now, it's been impossible to get most scientists to take any interest because the people in charge of earthquake research are seismologists and they're physicists, and they say it's got nothing to do with biology and this is just folklore, superstition, and that sort of thing. But interestingly, in the last few years, a few biologists have been taking an interest, and there's now really good evidence that animals can pick up when earthquakes and tsunamis are going to happen. What they've been doing, the official research programs, is putting sensors on domestic animals like goats or cattle and observing unusual patterns of movement. What they haven't done, but what could be done, is to engage the wider population. Almost everyone now has a smartphone, and if there was a simple app where whenever people saw unusual animal behavior in their own or in wild animals, they just pressed a button and put in a few bits of data, this could all be aggregated by a global company. Google would be great for this with Google Maps. And if there's a surge of reports from a particular area, it could easily lead in the end with more research to effective earthquake predictions based on engaging the attention of large numbers of people. This would not only be popular science in the sense it engages lots of people, it would be interesting science that would interest children and adults all over the world. And it would also be useful science, and it wouldn't cost very much. And yet, there's a tremendous barrier to getting this done because of these dogmatic assumptions within the scientific world. The barrier is less within the high-tech world. And I'm hoping to talk to people in Google and in other large-scale tech corporations with the hope of getting such a warning system developed. And that would be a very good model for participatory research, participatory science, and distributed gathering of data, rather than leaving it all in the hands of a tiny number of professionals in labs.
That's super interesting. And is it one of your books has a subtitle, a do-it-yourself, kind of a do-it-yourself guide? And it's 7 experiments that could change the world, I think. And the subtitle is a do-it-yourself, but what you're talking more is like the future scientist or the future of science, in a way where those would be done through the technology we have. So we are not Luddites here. We can embrace the technology, but to continue doing what you've been doing these many years, right? Which is real world, real experiences, things that are very normal and not paranormal, which is also a clash that's very strange, right? Because you mentioned the pigeons, or I mentioned telepathy a few moments ago, and many of the audience here would tolerate it, but many other people would immediately say, what are they talking about? Especially scientists, right? What are they talking about? Psychic research, paranormal research? And in a way we could say, yes, we're talking about that, but we're just saying, let's entertain that this is possible and let's do our best to test it. And then if you go back to the history of science, which I love, you realize that Newton and Bacon were alchemists, and that William James, the founder of psychology, was interested in near-death experiences, and then Marie Curie attended seances, and so on. Now, we could think, well, but we hopefully and finally got rid of all that superstition. But this is, again, a very skewed way of even telling history, not just science, like history. Sometimes I come across neuroscientists or scientists in general that interpret, and I mean, I claim no expertise in history, but they say things like, well, you know, Newton did that because in a way he had to please the church or whatever. But no, they were genuinely interested in any phenomena, like William James is the same. And so this is very, very normal in a way, what you're talking about, but super, super strange within the academic world.
Well, that's one reason why I think it's important to take the research outside the academic world. And in a lot of areas of biology, this can be done, because you couldn't do it in particle physics, where you need 10 billion euros to build a new accelerator, but you can do it if you're studying pigeons, or observing your own dog, or studying the feeling of being stared at. And another area which is usually treated as something that has to be depend on huge investment could actually be freed up, and that is health and well-being. Health and well-being has been left to large-scale institutes. In Britain, the Medical Research Council has this Cathedral of Science, the Francis Crick Institute in London, which is dedicated primarily to molecular biology and molecular medicine. The drug companies are obviously doing research on drugs, where there's a very strong bias towards the chemical side of medicine and also the physical side through surgery. And these have their role to play, and they're very important. But they're not very good at dealing with well-being. And one of the endemic diseases of modern secular societies is depression. I mean, something like, I've forgotten the statistics, 1 in 10 people are on antidepressants or something. Actually, I think it's higher than that. There's mental illnesses like depression plague the lives of and ruin the happiness of many people who, unlike people in the past who could starve or didn't have sufficient home comforts or heat or clothing or anything, people have got all those things, food, clothing, etc. And they're still depressed, angry, anxious, suffering terribly. Yet it's already known that spiritual practices like meditation can have a major effect in relieving depression. And this has been done partly through large numbers of people discovering it, partly through scientific studies. As I show in my books, Science and Spiritual Practices and Ways to Go Beyond and Why They Work, there are many simple spiritual practices that anyone can do that cost nothing, which can increase health and well-being. And one of the ones that I'm really interested in at the moment is fasting. All religions encourage periods of fasting in the Christian tradition during Lent, partial fasting or complete fasting for periods of time. Muslims fast during the daytime in Ramadan. Jewish people fast at Yom Kippur. Hindus and Buddhists have fasting days, and shamanic cultures have fasts before rites of passage or initiations or other ceremonies. Now, research on aging has shown that one of the causes of aging is senescent cells, which build up in the body and cause irritation. And there's billions of dollars being poured into aging research at the moment, largely by aging billionaires, and who, of course, want to find ways of extending their own lives. I mean, the quest for the elixir of youth is not a new idea, after all. But there is now a huge investment, billions and billions of dollars on senolytic drugs, ones that will help to break down these senescent cells that cause irritation. But actually, the simplest and cheapest way of doing it is to fast for several days with just water or fluids. And that will get rid of these, it'll detoxify and flush out toxins from the body. And I think that if health systems throughout the world promoted fasting, did research on it first and promoted it, the health and well-being of populations could be enormously improved at not only no cost, but negative cost, because if you're fasting, you don't need to spend money on food, you actually save money. But the trouble is, no one's doing that research, or hardly anyone's doing it, because the research by governments is all there to help industries, and the research by industries is to help themselves. And none of them are going to make any money out of fasting. But it's what national research efforts should be doing, and also what foundations should be funding. And so I think there are so many potentials for moving forward fairly cheaply and simply, as soon as we get out of the narrow framework that constricts normal scientific thought.
Yes, you see, what I love talking about, what I love about talking to you is that that's maybe a tendency I have of looking back and complaining about all the things that are going wrong, but immediately you present all this menu, pick your dessert, right? Like there's so many things in different areas that we could do, and they're full of potential and creative, and even with evidence. And in a way, it's also reinventing the wheel, if you think about it, because these traditions are not there for no reason. Like, this is millennial wisdom, if you want, and some of it may be biased and even wrong, but if science would go back to it and treat it not just as an object of study, but also like seriously. I mean, I make fun when I read, but I admire at the same time. I have a friend who does research on breathing and microbiota, the axis between brains and lungs and the stomach, right? And it's very funny when there's this big this paper in a big journal that basically it's proving that breathing well makes you feel better, or that if you eat better, you think better in a way. I know it's very simplistic, but I mean, this is common sense and common knowledge. Now, if we can just bring it together with science and even with technology and all these possibilities, we could be doing much, much better. But at the same time, I'm pessimist, because it's not just academia and what we were talking before. There are all these market forces, like very structural in our society, that, as you say, if you cannot make money out of prescribing people to go for a walk or eat better or sleep better, or in near death, which is a topic I'm really interested in near death studies. Like, sometimes people, yes, they need palliative care and drugs to avoid pain, but they also need professionals to be present there, and professionals are not trained or sometimes not able to do so. And it would be so simple. So it's very paradoxical. It's full of opportunity, and it feels like it's constantly at the verge of, but also wasted.
Yes, but I think one area of hope, you see, is the rise of consciousness studies, because after that bleak period of behaviorism in the 20th century, there are now people studying near-death experiences, psychedelic experiences, out-of-the-body experiences, and various other aspects of consciousness studies. And this, after all, is what is most neglected in mechanistic materialism. Mechanistic materialism treats the entire world as if it's made of unconscious matter working only mechanically. So consciousness is amputated from the whole of nature and from the whole of science. And this is obviously a very narrow view. It works very well for making machines and steam engines and jet engines and computers. It doesn't work very well when it comes to the effects of mind and on body, and placebo effects in medicine, spiritual practices and well-being, nor understanding the nature of our own minds or giving us any kind of wisdom about how we live. And I think consciousness studies is one of those areas that becomes part of the science of the future. And precisely because it was amputated from regular mechanistic materialism, it not only gives us a new view of our own potentialities and that of other animals, but also of the cosmos. Because if we take seriously panpsychism, which again is rising in importance at the moment, the idea that consciousness is not confined to brains and may even be present in electrons and atoms. If we take seriously panpsychism, then we see that consciousness may be widely distributed in the universe. It may indeed underlie the entire universe. And as you know, I published last year a paper in the Journal of Consciousness Studies called "Is the Sun Conscious?", in which I argue that many of the criteria we use for the interaction of mind and body, electromagnetic fields, the ability of organisms to modify their own state, many of these criteria apply to the sun, and the sun could easily be a conscious being, and so could other stars. Entire galaxies could have minds, galactic minds. The whole universe might have a cosmic mind. And this, of course, is not a new idea. Plato, in his Timaeus, talked about the world soul, and so did the great Neoplatonic philosopher Plotinus. And we could think of it as the world mind or the world field or the world consciousness. But when we look at physics, even cosmology, in these terms, where we, instead of pushing consciousness out of the scientific picture altogether, leaving the hard problem of consciousness, human consciousness, when we bring it back in, then everything begins to look different. And the science of the future, including consciousness instead of denying it, will not only change our understanding of ourselves, but our understanding of the whole of nature, the whole of the universe, and indeed, bring into play the question of the relationship between these other forms of consciousness, greater than our own in scope and possibly intelligence and creativity, and ourselves, and what is their relation. And that, of course, is the traditional area of spirituality and religion. So I think this could open a whole new possibility for dialogue between the realms of science and the religious traditions.
Yes, I couldn't agree more. And it feels like we're rediscovering that the world is enchanted, you see? Like there was this split, which was a very pragmatic, I mean, that's how I read history backwards, but it was a very pragmatical split. You could say, well, let's divide the whole of things into those that have mind and those that don't. And then physics did a lot of progress with it. Very soon, it wasn't so easy because it was like 300 years and we were with quantum mechanics again. But even before quantum mechanics, when Faraday or Maxwell, especially Faraday, was imagining how electric fields would be, or even, not only imagining, he was actually seeing them. Maybe he was under some psychedelics or endogenously produced. But anyways, like there was this split, which was like, okay, we'll deal with this first, the material world. Of course, that turned to be a big box of surprises because as I say, when we make this distinction between materialism or matter and mind, well, I don't think materialists take matter very seriously because matter is fascinating and even more mysterious than mind. But in any case, okay, we will solve material aspects, then biology, and then of course the temptation is say, well, biology is just a spin-off of physics, which I don't think it is. And then, okay, psychology, we know it's hard. And then, okay, mind and consciousness will do this at the very end, always postposing it. But as you say, it is coming back because at some point it's inevitable. Like we've looked everywhere and we cannot ignore this phenomenon anymore. And it turns out to be everywhere. So I still think that there's a lot of great work to do in terms of understanding matter, and not just scientifically, also philosophically, and also mind. And probably both things are aspects of the same reality. And so it's an amazing cocktail of history and physics and biology and even theology. And this is really fascinating to me as well, to realize that it's the same thing. We've been studying it under different conditions. And maybe that's the realization that will come soon, that we've been studying the same thing strategically, but it's all the same reality.
Yes. Well, I mean, there are groups of people discussing these already, and I'm sure the Paris Center is playing its part in this whole movement and development of consciousness. And the Scientific and Medical Network, for example, which every year has a conference called Beyond the Brain, and it has another conference called Scientists and Mystics. So they've been, and the Institute of Noetic Sciences, looking at these. So there are groups, fortunately, it's not just isolated individuals. There are now groups who are looking at these things and who are charting a way for the future of the sciences. And I think it has this, since we're discussing future of the sciences, there are several aspects. One, of course, is the applied sciences, because the reason science gets funded and the reason it has the high prestige it does is because it's useful, or some of it's useful. And in my own area, biology, the applications of biology are primarily in agriculture and medicine. And there again, there's great scope for research, and we've got to change the way we grow crops and the way we feed ourselves in the context of global heating. And that means changing our agricultural practices. We've got to move away from intensive fertilizer and pesticide use to more sustainable agriculture. We've got to move to more sustainable diets, less meat, and new ways of growing crops and indeed animals in harmony with nature, more use or acknowledgement of the role of mycorrhizae and symbiotic systems. In medicine, we've already talked about some of the areas that could lead forward, more emphasis on spiritual practices to help with well-being, including fasting. Then the exploration of consciousness, which is the really big thing that the science of the future will include, that the science of the past didn't include, with its cosmological implications, and also the possibility for researching the mysteries of our own minds, including things like the sense of being stared at and telepathy, psychic phenomena which we share with other animals, as well as spiritual phenomena which we may or may not share with other animals. Every time I think about these things, I realize how much potential there is for the sciences of the future. And when I pick up most scientific journals, I just feel what a shame that they're working within such a narrow, hyper detailed, it's sort of very good as far as it goes, with enormous detail, highly intelligent experiments and stuff, but always within this very, very narrow framework. And the sciences of the future will obviously have to have a larger and more inclusive paradigm, which is what your series and what the Paris Center are concerned with.
I think it's a great place to leave it. And let me just add that I think you embody part of what the future scientists will be or is, for the reasons we've discussed and others that maybe come now in the questions and answers. But let's leave it at that, because it's a good place to stop. Thank you, Rupert.
Well, thank you both so much for today's session, for the wonderful conversation, and for all these topics that you've risen today. And I also want to thank you all the audience for joining us. It's been really great, and thank you to everyone who's contributed in the chat with your questions or even just by being there. Just before we go, I'd just like to invite you all to the next session of this series, which is of the Future Scientists, where we will have a conversation between physicist and philosopher of science, Michel Bitbol, and Dr. Alex Gomez-Marin. The session will be on the 30th of March, where Alex and Michel will draw from the phenomenological tradition to explore the feasibility of a new kind of science in which human consciousness is placed at the center. We also want to invite you to our ongoing series here at the Party Center entitled Dualities, the Marriage of Opposites. In this series, experts and scholars will explore and examine the meaning of dualities in physics, philosophy, spirituality, literature, psychology, and reality. This weekend, we will have on Saturday, Dave Schrum discussing Beyond Dualistic Mind, journeying together on David Bohm's No Road. And on Sunday, we will have Mark Vernon, where he will be discussing The Master and the Emissary, Dualities and the Philosophy of Ian McGilchrist. So I hope to see you all at these events. In the meantime, if you want to contact us for any matter, you can use our website, social media, or email us directly at james@partycenter.com or eleanor@partycenter.com to contact Eleanor. Thank you all again so much for joining us. Thank you so much, Rupert. It's been an honor to have you. Thank you. Great to see you again, Alex. And we'll see you again soon here at the Party Center. Bye-bye.